Okay, so let's take a look at the CSIT CTF Mini CTF 2026 binary. So if we look at the imports, we open it in IDA, we would see that there's some sort of virtual protect, virtual alloc, so there's probably a second stage in there, and then we also see there's network operations going on. And so with this info, we can actually put in a breakpoint at some of these functions and then see what comes up from there. Okay, so let's go into X32 debug. If we go into symbols, we can take a look at let's take a look at WinHTTP, and then we want to see the read function probably to see what data is being downloaded. Yeah. Okay, so we are going to put a breakpoint where it returns. Okay, and then we'll just execute it. You need to execute it as admin, and then you also need plugins such as a sealer hide, which will hide the debugging that's going on. Okay, so it's already stopped at the breakpoint here. Let's step out of it, and then we can immediately see that we see the URL, the domain and URL that is downloading from, and we can visit this in a browser actually to get the payload. So there's a lot of decoding of the payload going on. There's a byte reversal and then reverse in the order of things. But if we want to, we can actually skip all that. So the second thing we look at would be if you look at strings on IDA, actually there's some interesting strings. So output.exe, we see it somewhere in the binary itself. So if we go into it and we see where it is actually being called, we can actually see that there's a sort of a jump here, and then it's either calling this function here or it's trying to output. So it could be that the binary has already been decoded and it's trying to output the binary here. So this could be one of the areas that we can breakpoint in order to get the second stage binary. Yeah. Okay, so let's put this breakpoint in on IDA on x64 debug itself. Okay, so here we can see that it's what we saw in IDA. There's this fail to resolve imports, and then the output thing. So it'd be best if we can breakpoint just at the jump here before it goes into either branch, just in case it goes into the wrong branch and then we are unable to get here. So let's restart it. Okay, so now we are here, and we can immediately see that there's actually a PE over here already. So what we can do is to dump it out manually. Obviously, you can actually look at the logic and see how you would trigger a jump into here and get it to really write out output.exe for you. But another way to do it is just to dump it manually. So we can see over here, the MZ header, and then we just dump this whole thing out. Yeah. X32 debug actually allows you to save it to a file. So this is what. Okay, and then we can actually select it all the way at the end. It doesn't matter that if there's extra junk at the end of the binary, you can still execute, which is the binary that we just dumped. So if we quickly take a look at imports, we can actually see a bit of crypto kind of functions. So there's hashing, there's also RSA that's going on, and then there's probably a bit of network operations going on as well. Yeah, RSA. Yeah. Okay, and if we take a look at strings, there's a way we can actually kind of shortcut this with a bit of logical deduction. Yeah. So we immediately see that there's 12 of these hashes here. So actually it's 32 characters long, so MD5 hash, and then we can see this huge length of sort of random kind of characters that is a space delimited. So if there's a bit of logical deduction that we can do is that possibly some of these values might be hashed into and end up as one of these hashes here. So what we can do is to write a quick Python script. So we'll go through this whole list. We'll split it because it's space separated, and then we'll figure out if any of this matches the hash over here, and then we'll print it out. Yeah. Yeah, so you immediately see that the pre-image of one of these hashes is actually here. which is one of the entries in here. And then if you try this for the second hash itself, you know, it's further down in here now. Yeah. And so if you continue doing this for all the hashes, you actually retrieve 11 of these pre-image, but you won't be able to find the pre-image for the last hash. And what you need to do, you can do a quick crack, or you can do a quick Google, you know, and then you'll see that for this is actually the pre-image is actually shadow. And actually, if you you know, change possibly one of these, or you just append shadow at the end of here, you realize that this is the last pre-image. We need to change this. Yeah, and then we get shadow here. Yeah. So how we ended up here, also another way that we actually did it, or how we realized this was actually when I ran this command, actually only 11 base64 encoded strings were set up. So we know that one of them is missing over here. Yeah. If you're interested in, you know, what is actually going on and how come the base64 string actually changes, what's happening is that, you know, it actually extracts an RSA key, public key, and then it encrypts it encrypts the crypt itself, the word itself, and then it sends base64 encodes and then sends it out. That's why each time it's different, but it only does this if it manages to match the hash here. So it didn't manage to match the hash for the last one, and shadow is missing. So at this point, what we can do is actually to patch the binary to change one of these values into shadow, and then when we execute the binary again, it should give us the flag. Okay, so we are at this point here, and what we need to do is change one of these unused values into shadow. So let's do shadow, and then we'll do a space. Okay, and then what we do is we save this as a patch binary. Okay. So now when we execute the patch binary, we should get the flag at the end of it. And here it is, the flag. So that's about it, and I hope that you've managed to learn something from this session. Thank you.